Hi students, welcome to DOPA classes. Today I am going to discuss a new very interesting session. The name is Electrostatics. All of you know that in plus 2 the first two chapters are related to electrostatics, which means the charge at a rest. Am I right? Okay, so here these two chapters is dealing with the charge at rest, and we can say these two chapters deals with the electric field. Ready? Okay, so these two chapters are considered chapters, which means all of you know that here the first chapter, that is electric charges and fields, and second chapter is electric potential and capacitance, and both together we can call it as electrostatics, because these two chapters are related with the charge at a rest. Okay, so here now I'm going to discuss some questions, some interesting questions about this section itself. Okay, so before taking the class, I want to clear one thing. I want to give you one short trick and one tip about the NEET exam. All of you know that to crack NEET exam, it's very difficult, right? Okay, but if you think or if you do very well in the right manner, then it's very easy to crack NEET. Okay, so here the tip for cracking NEET, that is, first of all, we need to stop studying over content. That's the main thing. That's the main thing you should need to do yourself. Stop studying over content. Just study the NCERT based section itself. That's enough for you. That's enough for you. Okay, don't study over content. If you study over content, then it's very difficult, or it's very there is a lot of mistakes or a lot of confusion in the when we're studying our content. Just focus on your NCERT textbook itself. That's enough for you to crack NEET exam. Ready? So that's the main tip, and there's a very important tip you should need to follow. Okay, now start the first question. Yeah, the first question, that is, the charge on two spheres are plus 7 microcoulomb and minus 5 microcoulomb respectively. They experience a force F if each of them is given an additional charge of minus 2 microcoulomb. The new force of attraction will be. So that's the question. Ready? So here in first case we have two charges, that is Q1, that is equal to plus 7 microcoulomb, and also Q2, that is equal to minus 5 microcoulomb. Ready? So here the force F is that is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by R square. That is equal to 1 by 4 pi epsilon 0, that means 9 into 10 raised to 9 into here Q1, that is plus 7 microcoulomb. So first of all I'm going to convert it into coulomb. So here 7 into 10 raised to minus 6 into what is Q2 here? Minus 5 microcoulomb. So minus 5 into, just convert it into coulomb. So here minus 5 into 10 raised to 6 by R square. Ready? So here, look at here, I'm just cancelling here. Minus 6, 9, so 3, then sorry, here this minus 6, right? So minus 6, then 3, here minus 3. Ready? Okay, so here 9 into 7 into 35, so we can write like this here, minus 35 into 10 raised to minus 6 by R square. This is equation number 1. Ready? The next, if we add minus 3 microcoulomb on both charge, so what will happen here? If we add minus 2 microcoulomb on each charge, so here Q1, that will become plus 7 microcoulomb minus 2 microcoulomb, that is equal to 5 microcoulomb itself. Then Q2, that is equal to Q2, that is equal to minus 5 minus 2, that is minus 7 microcoulomb, right? Before that, one second, have a small mistake here. Here no need to just take 1 by 4 pi epsilon 0, that's itself. So here once again 1 by 4 pi epsilon 0 itself, doesn't matter. So we get a, I'm cancelling here these two things. One second. Yeah. Here 1 by 4 pi epsilon 0 into, one second, this is minus 6 and also this is minus 6. So here minus 35 into 10 raised to minus 12 by r square itself. Yeah. No need to take the value of 1 by 4 pi epsilon 0. Okay. So here when we add minus 2 microcoulomb on each charge, so what we will get is f dash, that is equal to 1 by 4 pi epsilon 0 into, yeah, 5 into 10 raised to minus 6 into minus 7 into 10 raised to minus 6 by r square. So that is equal to how much? Yeah, 1 by 4 pi epsilon 0 into minus 35 into, yeah, 10 raised to minus 12 by r square itself. Ready? Look at here. On comparing equation number 1 and 2 itself, just compare equation number 1 and 2 itself. Simply we get here the new force of attraction is same, right? Look at here. Before that, I just do the value. I just given the value, right? So no need to give the value because we need to compare these two things, right? So here, when we give the when we add minus 2 microcoulomb on each side or each charge, we get the same value itself. So here equation number 1, that is equal to simply equation number 2. Thus we can say here therefore f dash, that is equal to f itself. Ready? Fine. So here the first question, in this first question, the right answer, it should be capital F itself. Got it? Ready? Yes. Yeah. There are a lot of people here. Paurnami, Shedima, Sharon, right? And Dharani. Okay, do you understand this question? All of you understand this question? If you understand, then we will go through the next question itself. Yeah, all of you done the question, right? Very good, very good. Then the next question here, the 3-point charges. So that's the second question. That is the 3-point charges. Yeah, 3-point charges Q1, Q2, then Q3 in the order are placed equally. Okay, placed equally spaced along the straight line. Okay, if Q2 and Q3 are equal in magnitude but opposite in sign. Okay, if the net force on Q3 is 0, then the value of Q1 is, that's the question. Okay, so very interesting question, and this type of question you can expect on your NEET exam itself, right? Okay, so here, yeah, first of all I'm drawing the 3 charges. Okay, so 3 charges are in the same distance, right? Just go through it. Here this Q1 and this Q2 and this is Q3. Okay, so here the distance between the both, I'm just given here, that is A, right? This A, and distance between Q2 and Q3 also A. Ready? Fine. And here in the question is given, that is Q2, that is equal to what? Q2 and Q3 are equal in magnitude but opposite direction. That means Q2, that is equal to minus Q3. Ready? Yes. So that's the main thing is given. And here, if the net force on Q3 is 0, that means the force on Q3 due to Q1 and also force on Q3 due to Q2, when we add these two things, we get the value 0. Ready? So here, the force on Q3 due to Q1 plus the force on Q3 due to Q2 must need to 0. That is given here. Okay, so here the value of Q1, that is the question. So just give the value here, F13. Yeah, F13, that is 1 by 4 pi epsilon 0 into, yeah, Q3. Yeah, it's Q2, once again, here Q1 into Q3. Ready? Clear? By, yeah, what is the distance? 2a all square plus 1 by 4 pi epsilon 0 into what? Here 1 by 4 pi epsilon 0 into here, yeah, Q2 Q3 by a all square. Ready? Yes. That is equal to what? That is equal to 0. Yeah, here plus of minus the, right? So here 1 by 4 pi epsilon 0 into Q1 Q3 by 4a square, that is equal to 1 by 4 pi epsilon 0 into Q2 Q3 by a square itself. Ready? So here, yeah, when we cancel this all thing, yeah, sorry, a square, then Q3. One second here. Yeah, of course, here when we cancel this all thing, we get simply Q1, that is equal to 4 Q3 is the right answer. Ready? Clear? Hope you all of you get the question itself, right? Ready? Yes. The next question. Continue. The next question, that is question number 3. Okay, before that, hope you got the answer, right? Yeah, all of you done the question. So option 1 is the right answer. I think the first one, who is done? The first one is done, right? Shuhaib, right? Shuhaib done the answer first time, right? Okay, good. Okay. Then the third question, the two particles of equal mass m and charge q are placed at the distance of 16 centimeter. They do not experience any force than the value of q by m. That is the question. Okay, so here, yeah, Shuaib done, that is equation 3 is given. Okay, right? Yes, we will try the question. Okay, so here if they will not experience any force, that means here the force due to, yeah, gravity, that is equal to electrostatic force, right? So in this case, yeah, gm square by, yeah, r square, that is 16 into 10 raised to minus 2 all square, that is equal to 1 by 4 pi epsilon 0 into what? Into q square by 16 into 10 raised to minus 2 all square. Ready? So here I'm just cancelling this 2. So we get a what? Gm square, that is equal to 1 by 4 pi epsilon 0 into q square. So here I'm taking this q square by m square in one side. So q square by m square, that is equal to 4 pi epsilon 0 into g. From this g by m, that is equal to what? Root of, once again, root of 4 pi epsilon 0 into g is the right answer. Okay, so here when we go for the option, here option 4 is the right answer. Yeah, here Dharni, Aisha, then Biji, Sundar, then Mashuda, and Bhagyasri, Helena also get the right answer. Very good, very good. Okay, hope you understand the question, right? Please respond, my dear students. Okay, very good. The next question. Yeah, this is a common question that is came more than one time in your NEET exam itself. Okay, here when air is placed, yeah, very good. Here when air is replaced by a dielectric medium of force constant K, the maximum force of attraction between two charges separated by a distance. That's the question. Here, all of you know, here in air itself, yeah, tell me, here in air, the value of force in air, that is F air, that is equal to 1 by 4 pi epsilon 0 into Q1 Q2 by R square, right? Yeah. Then in medium, which means in dielectric medium, here the F medium, that is equal to 1 by 4 pi epsilon 0 K Q1 Q2 by R square, equation number 2. Just divide equation number 2 by 1. So here what Fm by, which means F medium, that by F air, that is equal to, yeah, of course we get to 1 by K, right? From this force on medium, that is equal to force by air by K. That's the right answer. So here Fm, that is equal to force due to medium, is equal to force due to air by K, which means here there is the maximum force of attraction between the two charges separated by distance, that is decreases K times, is the right answer. So when we go for the option here, yeah, option 1 is the right answer. Yeah, very good. I think all of you done this question, right? Very good. Okay, so when we go for the option here, option 1 is the right answer. The next question, question number 5. Look at the question. It's a very interesting question. Here, a charged particle is shot towards another charged particle, capital Q, which is fixed with a speed v. Ready? It approaches capital Q up to a closest distance and then what? And then return. Okay. If Q were given a speed of 2v, which means it make into double, the closest distance of approach would be. That's the question. Okay, so here in this case, all of you know that this kinetic energy, that is will become the electrostatic potential, right? So here 1 by in first case here 1 by 2 mv square, that is equal to K small q capital Q by R square. That's the first section, right? Got it? Then if the velocity, it will become double. Here of course the distance of approach R will become R dash. Okay, so just give the value here. So the second case, it will become like this. Look at here. Here half m instead of v, it will become 2v all square, that is equal to K small q capital Q by R dash square. Ready? Clear? Yeah, this is equation number 2. Just divide the equation number 2 with the 1. So when we divide the equation 2 with 1, we get 4v square by v square, that is equal to R square. Sorry, here not R square here. Here R is there. So here R by R dash, right? I'm cancelling this 2 thing. So we get 4 by 1, that is equal to R by R dash. From this R dash, just cross the value. So R dash, that will become R by 4 is the right answer. Okay, so closest, the distance of closest approach will become 1 by 4th of the old one, right? So when we go for the option, yeah, option 4 is the right answer. Yeah, I hope you got the answer right. It's very brilliant. All of you done the question very well. Congratulations. Here the question first done by Dharani. Good, very good. The next question. Yeah, all of you done very well. Very good, very good. The next question here. Yeah, the force between two charges, the force between two charges 0.06 meter apart is 5 Newton. Okay, if each charge is moved towards the other by 0.01 meter, then the force between them will be. That's the question. Okay, ready. Here we know the force distance relation, right? Here the electrostatic force, that is inversely proportional to r square. From this we can say here therefore F2 by F1, that is equal to R1 by R2 all square. Am I right? So here, yeah, we need to find F2 because F1 is given, that is 5 Newton, and here R1, that also given 0.06, and here if each charge is moved towards the another by 0.01 meter, okay, then the force between them will be. That's the question. It's very easy. You can do yourself itself. Just tell me the answer. Which one is the right answer? Yeah, just give the value. Here we need to find F2. I'm not going to do here this question. This question is a very simple question. Which one is the right answer? Shuhaib is given option 2, and Dharni also given option 2. Yeah, very good. Then Biji Sundar also given option 2. Abindas, try once again. And Mashuda Fazana, they're also given, yeah, option 2. Yeah, the right answer, that is option 2 itself. So here option 2 is the right answer. Ready? Clear? Yes. Yeah, the next question. Next question. Here I'm giving the variety type of questions. So please focus on this type of question. Okay, this is the expected questions from this chapter. Okay, here a total charge capital Q is broken into two parts, Q1 and Q2, and they are placed at the distance r from each other. Okay, the maximum force of repulsion between them will occur when? That's the condition. Okay, how can we do it? How can we do it? All of you know here, yeah, here the total charge, that is Q1 plus Q2, that is equal to what? Q. Ready? Yeah. From this we can say here, so that here Q2, that is equal to Q minus Q1. Okay. In the first case, here the force F is equal to what? K Q1 Q2 by R square. Ready? Here, look at here once again the question. The total charge Q is broken into two parts, Q1 and Q2, and they are placed at the distance r from each other. The maximum force of repulsion them will be. That's the question. Okay, so here F is equal to K into Q1 Q2 by R square. All of you know that here. Yeah, then the Q2, the value of Q2 just given here. So here F, that is equal to what? K into Q1 into Q minus Q1 by what? R square. Ready? Yes. So here force will be maximum when? Simple. The force will be maximum when dF by dQ1 will become 0. dF by dQ1 will become 0. So just differentiate with respect to Q1. Of course, when we differentiate this section, yeah, here we get look at here, just differentiate this section. So we get a KQ by R square minus 2KQ minus 2KQ1 by R square, that is equal to what? 0. Which means here KQ by R square, that is equal to KQ1 by R square, that is equal to 0. Sorry, that is equal to 2KQ1 by R square. Just cancel the values. Here K, then R square. So we get to Q is equal to 2Q1. From this Q1, that is equal to Q by 2. Thus we can say here Q2 also, that is equal to Q by 2. This is the right answer. So when we go through the option, yeah, which option? Option 4 is the right answer. Yeah, here all of you done the question very well, very good, very good. Here, yeah, Shuhaib, first time you got the wrong answer, right? Don't worry, try the next session. Here, Dharni got the answer first time. Okay, very good. The next one, yeah, and shall we start the next question? I think hope you finished this question. Okay, here an uniform electric field E exists along along positive x-axis. The work done in moving a charge 0.5 coulomb through a distance 2 meter along a direction makes an angle 60 degree with x is 10 joule. Then the magnitude of electric field. That's the question. Okay, so here this is the electric field, and here it makes 60 degree. Okay, and moves 2 meter, right? So in this case we have to find electric field, right? So here work done also given. So all of you know what is the equation of work done, that is equal to Q E dot S, right? That is equal to, we can say here, Q E S cos theta. Ready? So what is the value of work done that is given? That is 10 joule, right? So 10, that is equal to, what is the value of charge? That's 0.5 into E, that we need to know, into 2 into cos 60 degree. Okay, so cos 60 and 2, just cancel it, because cos 60, that is equal to 1 by 2. So from this E, that is equal to 10 by 0.5, that is equal to 20 volt per meter is the right answer. Who got the answer? Right, 20 volt per meter, option 4 is the right answer here. Good. Okay, the next question. Here, look at the question. It's a very interesting question. The two identical conducting spheres, okay, carrying different charges attract each other with a force capital F, right, when placed in air medium at a distance small d apart. The spheres are brought into contact and then taken to their original position. Now the two spheres repel each other with a force whose magnitude is equal to that of the initial attractive force. It's a very interesting question. The ratio between the initial charge on the sphere is, that's the question. Look at here, look at here. Here in this case, in the first case, the two identical conducting sphere carrying different charges. Okay, I'm just given here Q1, Q2. Okay, so here the force F1, that is equal to what? K Q1 Q2 by R square. That's the first one. Okay, ready? Then they brought in contact and then return to its original position itself. So it will become here F2, that is equal to K into Q1 minus Q2 by 2 all square by R square. Yeah, here distance D is given, right? Okay, so just give, instead of R, yeah, D square. Okay, this is equation number 2. According to the question that is given here, yeah, these two forces are equal, right? So here F1, that is equal to what? F2. Just equate it here. When F1 is equal to F2, here what will happen here? Yeah, K into Q1 Q2 by D square, that is equal to K into Q1 minus Q2 by 2 all square by D square. Just cancel it. K D square, K D square. So we get Q1 Q2, that is equal to Q1 minus Q2 by 2 all square. Ready? Fine. Yeah. So here just simplify this all things. So q1 q2 that is equal to what? q1 square minus 2q1 q2 plus q2 square all divided by 4. Yeah. Then 4q1 q2 that is equal to q1 square minus 2q1 q2 plus q1 square. Okay. So yeah, when we doing this, we get a quadratic equation. So when we simplify this, which one is the right answer? Option 3 or option 2 or option 3? Which one is the right answer? Just go through it this session so you get the answer. Okay, so which one is the right answer? Yeah, all of you done here. Very good, very good. Manu is giving us a good evening. Okay, good evening. And Dia Parvin, yeah, Dharni option 3, right? Purnima, good. Then Bijay Sundar, also good. And here Aisha, option 3, C, good. Dia Parvin, yeah, all of you done very well. Okay, then Kabir Naha is given 20 volt per meter. So which answer is this is a question number 8, the previous question, right? Okay, anyway, very good. Then the next question. Yeah. This is the above average level question. Please go through it. Please go through it. Here, a charge capital Q is placed at each of the opposite corner of the square. Yeah, so first of all, I'm just drawing a corner. Oh, sorry, a square. Okay, this is the square, right? And here each of the corner, that's capital Q, right? Okay. And the next section here, a charge small q is placed at each of the other two corners, which means here in the other two corners we have small q. Ready? Okay. If the net electrical force on capital Q is 0, then the capital Q by small q is equal to. So that's the question. Okay. Here, yeah, let F be the force between the two charges, capital Q. Okay. So here, look at here. In this case, this is the charge capital F. Okay. Sorry, this is the force capital F between these two charges, these two capital Q. Ready? Okay. Then the force between small q and capital Q should be attractive, so that the net force on capital Q be 0. Okay. For net, yeah, and here I'm just given here the force between the small q and capital Q, that is F dash, right? So here I'm just given here this F dash and also this F dash. Okay, so due to this we have a resultant force capital R. Ready? Fine. Okay, so here in this case, for equilibrium, once again I'm just telling once again here, yeah, the force due to the force between the two capital Q, that is capital F, and here the force between small q and capital Q, I'm just took it as F dash. Ready? And here I'm just giving the length of the square. Here, if length of the square is L, yeah, here this L, so this diagonal it should be root 2L, right? Okay, so here for equilibrium, all of you know that here the resultant force, the vector resultant force, plus here the F that is equal to 0, vector F that is equal to 0. Ready? Yeah. Now here, what is the resultant force? It's very easy from the section itself. Here F that is equal to root of F1 square plus F1 square, that is equal to root 2 F1. Ready? Okay. And here, just give the value here, the 4 root of 2 F1 or root of 2 F dash, right? F dash, right? Root of 2 F dash plus minus or plus F that is equal to 0, which means here root of 2 F dash that is equal to minus F. Then just give the value here. So what is F dash? That is the force of attraction between capital Q and small q. And what is F? That is the force between the two capital Q charges, right? So just give the value here. Yeah, I know this is some complicated question, but we need to focus this type of question. Okay, so here root 2 into F dash, that is the force between capital Q and small q, that is 1 by 4 pi epsilon 0 into capital Q small q by, yeah, here the length, that is L square, right? L square, that is equal to minus of, yeah, tell me, 1 by 4 pi epsilon 0 into here F, that means the force between these two, right? Capital Q and capital Q itself. Okay, this two. Okay, so here 1 by 4 pi epsilon 0 into Q square, capital Q square by, here the length between this two capital Q, that is root 2. Okay, root 2L. So root 2L all square. Ready? Clear? I'm just cancelling the all thing here. Yeah, 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, Q, 1 Q, and here also L square, this L square. So here when we do is, we get root 2 into the remaining small q, that is equal to minus capital Q by root 2 all square, that's 2. From this, here, just take the Q by Q. So Q by small q, that is equal to minus 2 root 2 is the right answer. I know this is some complicated question, but you should focus this type of question. Okay, ready? Clear? The first all questions we discussed the average type of question, and this question is above average question. So if you have a capability to do this type of question, then it's very easy to score the NEET exam for this chapter. Okay, so here, yeah, when we go for the option here, which one is the right option here? Option 4 is the right answer. And when we go to the option here, yeah, the first option is given from Aisha itself. Very good, Aisha. Then all other done very well, very good. The next question. So shall we go for the next question? Hope you understand this question, right? Okay. Shuhaib, you are a little bit late, but no problem. Next question. Yeah. Next question. Yeah, for Manu, it's a very simple one. Very good. A charge small q is placed at the center of the line joining two equal charges capital Q. Okay. The system of three charges will be equal if small q is equal to. That's the question. So look at here. Here, a charge small q is placed at the center of the line joining two equal charges capital Q. So look at here. This capital Q, and there's also capital Q, and between I just took a small charge, small q. Ready? So the distance between both section, that is I just given here x and x. Okay, so here for equilibrium, the charge B, I just considering the once again I'm just writing the name here, charge A, B, and here C. Okay, so for equilibrium I'm just considering the B, I'm just considering the B here. So here the net force, that is equal to 0, so that we can say here the force due to A, that is equal to force due to B itself. Ready? Yeah, now just do it. Yeah, all of you get the answer very well, right? Very good. So here 1 by 4 pi epsilon 0 into capital Q small q by here x square, that is equal to what? 1 by 4 pi epsilon 0 into q square by here, yeah, 2x all square. Cancelling this all thing, q small q x square, and here also x square. So here we get a small q, that is equal to capital Q by here 2 square, that is 4. Yeah, here we have in minus, right? Okay. So here small q, that is equal to minus q by 4 is the right answer. So when we go for the option, here option 2 is the right answer. Ready? Yeah. So option 2 is the right answer. Just go through it. There is also the common question that came in the NEET exam. And the next question. Yeah. This is another NEET exam question. Okay. The electric potential V is given as a function of distance x by V is equal to 5x square plus 10x minus 4 volt. Okay. The value of electric field at x is equal to 1 meter is. It's quite easy question, right? Okay. So what is our value is given here? V is equal to 5x square plus 10x minus 4. All of you know here E is equal to what? Minus dV by dx. Just differentiate this equation with respect to x itself. So here that is equal to minus d by dx 5x square plus 10x minus 4. Okay. So while doing this, yeah, here we get E is equal to minus 10x plus 10. Ready? So at x is equal to 1 meter, that is given. So here E, that is equal to minus 10 into 1 plus 10 itself. So minus 20 volt per meter is the right answer. Okay. So minus 20 volt per meter. Yeah. Option 4 is the right answer. Ready? Hope you're getting the question, right? Yeah, I'm just going a little bit speed because you need to manage the time also. Because here endurance, that means what? Simply we can say the endurance, that is knowledge plus timing, that is equal to endurance. I know all of you know the knowledge, but if you go through or if you done the question with taking more time, then it we didn't get or we know does not get the NEET exam. Okay, so please focus on the time also. Okay, the next question. The next question here, question number 13. Yeah. Here, two metal pieces having a potential difference that's given 800 volt are 0.02 meter apart horizontally. A particle of mass 1.96 into 10 raised to minus 15 kilogram is suspended in equilibrium between the plates. If E is the elementary charge, then the charge on the particle is. So that's the question. Okay, here in equilibrium, here force F is equal to QE, that is equal to what? Yeah, here QE, Q means what? We can say N into E, right? Into E, that means I just put here in terms of electric potential, that's V by D, that is equal to what? Mg. Ready? Clear? Yes. So here, yeah, we need to find what the charge on the particle here. Okay, so here we need to find n, right? So here n, that is equal to mgd by E into V. So what is m here? 1.96 into 10 raised to minus 15 into 9.8 into d. How much is the d here? 0.02 by, yeah, E, that is 1.6 into 10 raised to minus 19 into V. V, that means 800. Just do it, we get the value. So which one is the right answer here? Just go through it. Just do the calculation. Simply we get here, when we cancel the both section, we get 3. 3 is the right answer. So option 4 is the right answer here. Ready? Good. Very good. Option 4. Yeah, all of it done, right? Dharini, Aisha, Faraz, but Dia got wrong answer. Kabir also got wrong answer. Doesn't matter. Just make it clear. Mashuda Fazana is get right answer. Anand, Bijasundar, Shifa Chippu. Yeah, very nice name. Also get the right answer. And yeah, Dia Parvin got wrong answer, right? Oh yeah, Dia Parvin also get right answer. Okay. Here, option 4, yeah, 3 is the right answer. Good. The next question. This is the previous year question. Just focus on the question. Here, the electric potential at a point in free space due to a charge capital Q coulomb is Q into 10 raised to 11 volt. That means here, V, that is equal to Q into 10 raised to 11 volt. Okay. Fine. So which means here, yeah, V is equal to 1 by 4 pi epsilon 0 into Q by R, that is equal to Q into 10 raised to 11. Am I right? Yeah. So from this itself, we can say here, yeah, when we just cancel the values here, yeah, when we cancel this 2, here we get the value 1 by 4 pi epsilon 0, yeah, into R, that is equal to 10 raised to 11. Okay. So from this, R is equal to 1 by 4 pi epsilon 0 into 10 raised to 11. Okay, question number 1. And here, we need to find the electric field, right? So what is the equation here? E is equal to what? V by D. Just give the value. That's it. Yeah, here equation number 2. Okay. So from equation number 1 and 2, just give the value, you get the answer. So here, that is equal to V, that is Q into 10 raised to 11 by 1 by 4 pi epsilon 0 into 10 raised to, 10 raised to 11. One second. Here, 1 by 4 pi epsilon 0 into, in denominator itself, here we have 10 raised to 11, right? So 10 raised to 11. So we get a 4 pi epsilon 0 into 10 raised to 11 into 10 raised to 11, that is 10 raised to 22 into Q. Volt per meter is the right answer. Ready? How many got the right answer? Yeah, in the question itself, here the answer, that's option 1 is the right answer. Yeah, brilliant. Ready? The next question. Here, a drop of mercury of equal radii possessing equal charges combine to form a big drop. Okay, then the capacitance of bigger drop when we compare to each individual small drop is? So that's the question. Okay. Here, yeah, a drop of mercury is equal to radii possessing equal charge combined to form a big drop. That means here the volume of 8 small drop, that is equal to volume of bigger drop, right? Then just give the value here. So here 8 into 4 by 3 pi small r cube, that is equal to 4 by 3 pi r cube. I'm cancelling here 4 by 3 pi, 4 by 3 pi. So we get r is equal to 2r. Ready? So as the capacity is against r, hence the capacity becomes 2 times. So the option 3 is the right answer. Ready? Okay. So here option 3, that is the right answer. 2 times is the right answer. Yeah, very good, very good. All of you get the answer, right? Good. The next question. Shall we start the next question? Okay. Yeah. The next question, that is here. The energy stored in the electric field produced by a metal sphere is 4.5 joule. If the sphere contains 4 microcoulomb charge, its radius will be. That's the question. Okay. Yeah. Here the energy of sphere E. One second. Here energy of sphere E, that is equal to Q square by 2C. Here energy of sphere, that is given. Okay. 4.5, that is equal to here Q, charge also given 4 microcoulomb. For 4 microcoulomb means 4 into 10 raised to minus 6, right? So 4 into 10 raised to minus 6 all square by 2C. Ready? From this we need to find C first of all. Here C, that is equal to 4 square, that is 16 into 10 raised to minus 12 by 9. That is equal to what? That is equal to 4 pi epsilon 0 into R. Am I right? Yeah. So from this it's clear that here therefore R, that is equal to 1 by 4 pi epsilon 0 into 16 into 10 raised to minus 12 by 9. Okay. So 1 by 4 pi epsilon 0, that is 9 into 10 raised to 9 into 16 into 10 raised to minus 12 by 9. Here I am cancelling here. 9, then 10 raised to 9, 10 raised to minus 12. So we get 10 raised to minus 3. Okay. So here we get 16 into 10 raised to minus 3 meter, that is equal to 16 mm. That is the right answer. Ready? So we get 16 mm, that is option 4 is the right answer. So how many got 4? Option 4. Yeah, very good. Dharni got the first time, right? So Dharni got the answer first. So give some. Yeah, very good, Dharni. And here the Kabir doing the previous question, right? Okay, good. Yeah. BG Sundar also get the 4, option 4, very good. Yeah, then next, please go through the next question. Here, the 2 similar conducting sphere, this is a very interesting question, okay, having charges 40 microcoulomb and minus 20 microcoulomb are some distance apart. Now they are touched and kept at the same distance. Here the ratio to the final the ratio of the initial to the final force between them is. That's the question. Okay. Here, look at here. The first of all, I'm here drawing the first case. The first case, that is, here we have 2 charges. That is, first one is 40 microcoulomb and second one is minus 20 microcoulomb. Ready? And they kept at a distance, yeah, D. I'm just giving here D. Ready? So here the first force F1, that is equal to what? That is equal to K. All of you know 1 by 4 pi epsilon 0 into, yeah, 40 into what? 20 by D square. Okay, I'm just taking the magnitude itself, D square. Okay, equation number 1. Then here, after touching, the question is telling here that here after touching or after contact, and it kept the same distance small d. So here the Q, the charge will become what? 40 plus of minus 20 by 2. That is equal to 10 microcoulomb. So the charge of each sphere, it will, or each spherical shell, it will become 10 microcoulomb. Ready? So here the second case, that means here now after touching it, the both will become 10 microcoulomb, right? Now F2, that is equal to K into, yeah, 10 into 10 by D square, equation number 2. Yeah, just divide the equation number 1 with 2. So that is here F1 by F2, that is equal to what? Here F1, that is 40 into 20 by 10 into 10. Other all thing, yeah, 10 into 10. Okay. Okay. So here other all thing will cancel each other. So here 0, 0, 0, 0 to 4 into 2, that is 8. 8 by 1. So 8 is to 1 is the right answer. So who get the right answer first? Yeah, Faraz got the right answer first. Okay, very good, very good. So 8 is to 1 is the right answer here. So option 1 is the right answer. Okay, ready? Then go through the next question. Yeah, another interesting question. About the electric potential, right? The electric potential at a point x, y, z is given by, that is given V is equal to minus x square y minus x z cube plus 4. Okay, so here the electric field E at that point is, that's the question. So what is the equation? All of you know the equation, right? Here E is equal to what? E is equal to minus dV by dr. Ready? That is equal to what? That is equal to minus dV by dx minus dV by dy minus dV by dz. Am I right? Yeah. So just differentiate the all thing with respect to x, then with respect to y, then with respect to z. So here, look at here. First of all, I'm going to differentiate with respect to x. So here, look at here. When we differentiate with respect to x here, when we differentiate with respect to x here, yeah, minus x square y minus xz cube plus 4. Look at here. 1 second. Yeah, minus dv by dx. So minus x square y will become 2xy plus z cube, right? Yeah. So 2xy plus z cube. Then minus dv by dy. Look at the question here. When we differentiate with respect to y, so it will become minus x square. So minus of minus x square, it will become x square itself. Okay, so x square. Okay, okay, minus dv by dou v by dou y, that is equal to x square. Ready? Then here minus dou v by dou z. When we go through the dou z, it will become 3x z square. So if you add the all thing, we get the value. Ready? So that's it. So when we go for the option, Which one is the right answer here? Of course, here, yeah, option 1 is the right answer. Ready? Clear? So hope you got the all section itself. Thank you very much. Then the other section we will discuss on the next class itself. Thank you.